moving on to the next concept of Kirchhoff's equation. Now, if you remember when we were dealing with the delta H, we came up with this equation in which we have the stoichiometric coefficient of the different species of the reactants multiplied by the enthalpy of the individual products, the summation of those, and when we subtract the summation of the stoichiometric coefficients of the reactants with their enthalpies, we get the delta H of the reaction, right, in equation 27. Also, when we were discussing specific heat capacity, we understood that Cp is basically del H del T at the rate of change of enthalpy with temperature at a constant pressure. Now, when we have this equation, let's differentiate this equation with respect to temperature. So, in here what we do is we differentiate the change in enthalpy with temperature at constant pressure. So, keep in mind that we are not just trying to differentiate enthalpy by temperature, we are trying to differentiate the change in enthalpy with respect to temperature at a constant pressure. Now, this what will happen in here? What we'll get here is so the stoichiometric coefficients come out. This thing becomes delta Hi by delta T at the constant pressure, and this is for the products minus the summation of the stoichiometric coefficients come out, they being constants, del of Hi by del T constant pressure for the reactants. Okay? Now, we know that del H by del Tp is Cp. So, we can use this formula, we can use this equation in here and simplify this. What we will get is, we will get delta, this remains the same, this becomes the Cp of the individuals and this being the product minus Cp of the individuals and the reactants. Okay? Now, this whole thing, the right hand side of this equation can be simplified by, so you see how we are getting the stoichiometric coefficients times the Cp of the products minus the stoichiometric coefficients of the Cp of the reactants, right. So, this can be easily substituted and written as, so we can write the same thing of the delta H delta T at constant pressure is equal to the delta of the Cp. So, this whole thing is just delta Cp, right, because this is how we used to write the delta H previously, and this is the exact same thing what we are doing for the Cp's, just the representation. So, this means this, right. So, it is an easier way of representing this. So, we got this equation, let us number this as 31. So, this equation is called Kirchhoff's equation, which is basically used to find out how the delta H is changing as a function of temperature. So, delta H of any reaction is going to change with temperature. The delta H of any reaction is not the same for all the temperatures, right. So, how how do you know what's the difference between the delta H of at one temperature versus at other temperatures? So this equation will tell you that. So Kirchhoff's equation will basically tell you how the delta H is going to change as a function of temperature. Okay. Now this Kirchhoff equation is valid for like any reaction that does not have any phase change in it. Okay. So if there is no phase change like solid to liquid, this equation is valid. Now how will you use this equation to do phase changes? You have to include those values. So if you have phase changes in any reaction, you have to separately include the enthalpy changes, the Cp and all the other thermodynamic variable changes that is going on, the heat capacities and other things in that equation. That should be included in the Kirchhoff's law to actually find out the enthalpy change in a reaction which has phase changes in it. So generally this is valid for any reaction that does not have any phase change. If you have a phase change, you have to additionally supply those heat capacity and other variables that are changing for the phase changes in this equation to find out the change of delta H by delta T. Okay. All right. So with equation 31, we move on, and I'm just writing this equation again. So delta H by delta T at P is delta Cp. This is 31, right? So this is basically the temperature coefficient of the enthalpy of the reaction. And what will be its unit? The unit will be the same as unit of a Cp, right? So this is basically heat by temperature. So joules by Kelvin, okay? Now, this is the temperature coefficient. So delta H by delta T is just the difference between the heat capacities of the reactants and the products. So you get the heat capacities of the products and subtract them with the heat capacities of the reactants, you get the delta H. So you get the temperature coefficient of the enthalpy of the reaction. Okay? Awesome.